Welcome all. Today we are going to see that map coloring problem. So this is which is a classic example of constraint satisfaction problem or CSP. So the main objective of this map coloring problem, so we are going to construct the color for the each region. So for example, we are going to choose red color or green color or blue color. So whatever it may be, so it should be going to represent like the unique color. So when we are going to compare to the neighboring region, it do not match or do not maintain the same color. That is the main condition for this CSP problem. So here we are having the some different kind of the variable of the regions and then domains. It should be specified in the particular problem over here. So here we can take like the variable as a region. For example, different kind of the country names or location names, etc. So this is one of the first statement for the variable. After that, we are going to consider like the domain. So domain means what now? It should be like connected with the each variable with mentioning the some color. So set of color we are going to maintaining, not only the particular for red, green, blue. So whatever the comfortable thing, so we are going to take it. Okay. So the CSP problem, it will be just main focusing for we are going to define like the variable. It could be represent like the region wise, and then domain it could be taking or connecting to the variable which it should be present into the color. Okay, so the main constraint or main rule is what now? So we are going to maintaining the each region or variable, it should be present as a each like or unique domain colors. Okay, that is the main condition. It do not continue or do not match with the same color in the neighboring region or variable. So this is the main condition. And the neighboring region, we are having the different kind of the regions. So this is the example of pair of the position. For example, the WA and then NT. So WA in the thing what now? So we are going to see the each and every country names. Okay, so now we can just discuss with the different kind of the colors. So what are all the colors it's going to pair? For example, WA and NT as the one of the country means. So for example, WA we can take like the Western Australia, and the NT as a Northern Territory. Okay, so these are all the two countries. So we are going to map with the color. It could be represent like the domain wise now. For example, the combination we are going to make it like the red green or red blue or green red or green blue or blue red or blue green. So these are all the possible level of the different kind of the color domains. It could be represent like the WA and then NT of countries. Okay, so this is one of the connectivity of variable and as well as the domain colors. The next one, the constraint can also be represented as a inequality. For example, we don't like the want the inequality means what now? So separate color we have to maintain. Okay, so for example, the red, green and red, green like that. Okay, unique only any single color only we are going to maintaining. This is one of the inequality. This is the equal, but what now we want to check with the different unique colors. Okay, for example, we can connect with the neighboring now. So we have to maintain the unique color does not match with the same color in the nearest position. So this is the main rules for this map coloring problem. So this is one of the map coloring of diagram. Okay, so this is the different kind of the country names. So this is one of the map. So the first one, WA, we can call it as a country for Western Australia, and then this one is as a Northern Territory and Queensland and South Australia and New South Wales and then Victoria and then the Tasmania. So different kind of the countries it should be present here. So here we have to maintain the three kind of the set of conditions. The first one, variable it can be represented as a x as a set of the rule. The x of set of rule, it can be combined the different kind of the countries. It should be represented as a short form. For example, WA and then NT and then Q, NSW, V and SA, we want to, and then T, we want to make with the like the short form of the country names. So that the thing we are calling as a variable. And then domain already we know, so we can represent like the capital D of I as the one of the connectivity for the domain, and we have to just connect the different, what are all the possible way of colors we can take it. Okay, and then the main condition is what now, the constraints. So here the constraints is that the main constraints we are going to maintain like the adjacent regions with the different color of the levels. So this is one of the main things. So the main goal, we have to assign the color with the satisfy with the adjacency constraints. So adjacency constraints of the satisfying color means what? We have to just maintaining the neighboring region as a different color. We know no need to maintain like that. We don't want to maintain, no need to maintain the same color. That is the main condition. Okay. And next one, this is the proper way for the complete diagram after the color is going chosen. Okay, so variable and then domains and then constraints. So now we want to just fix with the WAIA as a red. Here we want to make with the red as a western territory means. Okay, so here just what are all the possible way of the connection like the NT and then the Q means. So we want to just choose with the different color, like this is the red color we have chosen. So apart from the red color, we want to choose with the any two colors. So any two colors definitely we have to present over here. Okay, so for example, northern NT we can choose with the green means, and here we can just take with the take with that like what now, the blue color. Okay, so here whenever the condition we want to check, we don't want to repeat the neighboring as the region of colors. Okay, so for example, the red and then green and then blue. So we don't want to repeat the color, and whenever we can check with the constraint rule or adjacency region rule, so we can maintain that unique color or the specific color, and we don't want to like focusing on the same color. Okay, that is the main rule. The next one, Queensland. So Queensland, in what are all the possible way we can it nearby the connection with the NT and then this one. Okay, so what the thing, we are going to the south Australia. So what are all the possible color for the Queensland means, so we can choose with the only one color like the red color only here. And the next one, the north the new south worlds means, what are all the possible color, the nearest neighboring is as a blue, and then here the red color. So only one possible color is what now, only one as the green color here. Okay, we want to fix with the green color. And next one, this is one of the like water. This is one of the Victoria. So Victoria, this country is going to choose like what are all the possible color means. So here the neighboring region, it should be present like the blue color, and here it should be present like the green color. So what is the maximum maximum no? So maximum the coverage of the color is like what now, only one as a red color. Okay, and this is one of the separate country over here, Tasmania. So whatever the color we want, or we can choose with any color. Okay, what the thing we want to choose, we like that we can choose it. Okay, this is for the some the part of our constraints. Okay, so for example, red color we want or blue color we want, whatever the thing we want to choose. Okay, so these are all the complete constraint adjacency graph of the problem. Okay, as a human we know easy to represent like, okay, we have a sense and then we have the observation. Okay, this color we don't want to repeat, and this color as a unique color. Okay, as a human we know, but in the algorithm wise we want to go with the thing, you know. So we have to just go with the method for the constraint graph. Okay, so constraint graph, based upon the constraint graph we want to represent with the coloring function. Okay, so what is meant by the constraint graph? So this is one of the nodes represent with the variable or region. So these constraints, it could be just between the neighboring region and then the graph, this graph, it should be like dependent and making the problem solving. Okay, easy to solve the problem. Okay, so easy to just connect with the proper way of the process. Okay, so this is one of the thing, like it could be like the directional graph. Okay, so it can be connected the variable and then edges also. Okay, so for example, wa, what are all the nearest position of region, it could be connected, and this country, what are all the nearest position, it should be connected, like that. Okay, so this is as yeah one of the constraint graph of the problem. So based upon this method, how we are going to map with the color. Okay, so we can see the next slides. And one more thing before going to the before going to the constraint graph. So we have to know the backtracking algorithm, because what now, the backtracking one of the important technique for solving our correct and proper fixing our colors. Okay, so constraints means what now, so we have just using the graph representation with the help of the edges and then nodes or region. We want to just color fix with the color, and then after, what are all the possible way of the countries or nearest by the region, we are easy to connect it. Okay, but the backtracking, so we have to go with the backtracking like the top to bottom or bottom to top. Okay, basically the bottom to top, it will be just always connect into the backtracking method. Okay, so what is meant by the backtracking? So always it should be like work with the depth first search method. So this is one of the important method for solving the search space, and always it could be just taking with the potential and then good solutions. Okay, so this is one of the thing, and this is one of the popular method for the data structures also, and then CSV problem also. Okay, so it will be just giving the proper solution. Okay, so analyzing the for all end, like the left to right and then top to bottom, everything it will be analyzing, and then we will get the proper solution. So that is the main reason for taking this. And this is the one of the connecting for all kind of the variables, and then assigning values, and then recursive checking. Okay, and then the what are all the variable, and then what are all the domains it should be present, always it will be take over for this. Okay, so and then finally we will get the proper solution also. That is very important thing for why we can choose with the backtracking algorithm, because the constraints and then the fixing the color as a human we know, but in the algorithm wise we want to go now how we are going to solve it. Okay, that the thing also we can see the next slide. And the backtracking algorithm, we want to choose like the three kind of the component. Okay, three kind of the component. Based upon the component, always we are going to solve this way. So the first one, variable ordering, and then the value ordering, and then constraint propagation. So variable ordering, it should be like order, and then the chosen with the variable in the ordering way, like the each and every variable, it should be like the some order way, like numbering wise, and then order wise we are going to choose it. And then value adding. So value as a variable is known as the value adding, because this is the variable, whatever the ABC, some number letters or variable it should be present, means always making with the variable ordering. This is the value ordering. And constraint propagation. Constraint propagation, always it could be like the connected with the some constraints variable, it should be coordinating the position of the level. Okay, and it could be like reducing the domain variable based upon the complications. Okay, so maximum we can reduce the like what the domains means in a different regions. Okay, so this is the variable ordering, value ordering, and then constraint propagation. So this is the graph of the backtracking process with the help of the depth first search. Okay, so this is the graph. Based upon the graphs, we want to make with the graph, like the first one, this is the parent node, and then parent node, the empty node, it will be connected to the two nearest position. Okay, so first one, WA, that is a Western Australia. What are all the possible color? So we are having the three variable of colors. Okay, red, green, blue. So with WA, it could be like represent like the first color of red, green, blue. So first we want to go with the depth first search. Okay, depth first search, and then after we can use with the backtracking. So first we want to select with the red. So WA, once we can fix with the red, means next country is what possible country is NT. Okay, so NT. What are all the other position of the color we want to assign here? We have only the two colors only. Okay, the green and then blue. So our condition is depth first process. Now we can go with this left position. Okay, so what is the next thing? Next thing of country, for example, WA is over, NT is over, and then Q. So Q means what? Only one we are having the color, because the red, green, red, and then other is red, green, blue. But this is the nearest position, because the red here present, and then the Queensland is what now? The nearby the location, like the northern nearby the location, Queensland. Okay, so this is the order for the thing. So that here we want to take with the red color, means we don't have any problem, because this is one of the unique color. Okay, so that's why we can go with the red color. Okay, so here we just maintaining the three different colors for the particular regions. Okay, so based upon the region one is we can take it. So this is one of the backtracking. Again we can go with the what is that thing, next one. The next one is as a southern region. So southern region means what? Here we are going to fix red, green, and then red. So only one color only left we are having. The blue we can choose it here. Okay. So analyze those things and then fix. And then here the north, the new southwards. So here already fixed with the Queensland as a like what? The red color, and this is one of the like blue color. Sorry, yeah, yes, yeah, blue color. Okay. So now what the thing we want to choose? Like here as the yeah, green color we want to choose, and then follow by the green means, so here we are having the like what, the Queensland as a blue, and then here as a yeah, green, red. So apart from that, these color we want to choose with the victory as a different color over here. Okay, and then here that Tasmania, whatever the color we are having the comfortable, we can would like to we can like to collect or connect with the any other color. Okay, because this is one of the separate region over here. So this is the way for the backtracking. So backtracking, in that already we know the main top of the function, it should be connected into the depth level, and then again it goes to the back end, back to the front end, and then again we it will be checking into the what all the color it should be present over here. Okay, this is one of the sample structure for connecting the backtracking function. Okay, and the next one, this is one of the most constrained variable for using the with the help of the degree based, like what now? So what are the connecting way? Okay, so the tiebreaker among the connected things. So for example, this color, and then the green color, and then the red color, what are the basic way? For example, the connecting the portions. Okay, so this is one of the another example, but this is for simply, like how it should be presented for the branches wise, and then the connectivity process wise, like that. And next one is, this is the backtracking algorithm, very important thing. So for example, the initial state is, what is the initial state? It should be present, and then we have to analyze the all state space of search thing, and then we have to assign the some one color. Okay, that color is satisfied. Satisfied means we can continue with the next color of the decision point. Okay, otherwise we can not satisfying means what now? Again we have to go with the backend process, that is a starting position. Okay, once the condition is satisfied means we can continue with the next portion, and then the goal state we can reach it. Once the goal state it should be reached means we can just continue with the next state of problem. Okay, so this is the basic thing. So from state, and then the end state as a very important thing, and then the intermediate thing. So what are all the condition we are going to fetch into that, the based upon the condition we want to choose with the backtracking process over here. So this is one of the important thing. And next one is the forward checking. So forward checking, it can be improves the backtracking by tracking possible ways for the assigned variable. After the each assignment, if assigning a value, remove the all possible options for the another variable. This algorithm immediately stop and then backtrack. Okay, so it can be just to reduce the search space and speed up the computational level. So that is one of the very important thing. Okay, so forward checking always it could be like forwarded to the next step of the process. Okay, maybe it could be the assigned the value, it will be matched or not, but it will be just repeatedly it will be going. The main idea for what na, keep track of the remaining legal variable, and then whatever the thing, whatever the signal is not there means we can easy to terminate the process. Okay, so that is the thing. For example, this is one of the first track. Okay, so the country names and then first track, what are all the possible way of the colors. So first one we can choose with the red color for this position, means after that the two colors are left here, and then once we can decide with the blue means the next one, what are all the possible, the green, and then after what are all the possible, okay, possible color over here, the two possible thing, and then after three possible thing, okay, the SA as the this is the possible and T as the all possible way. So based upon the like the forward checking as going to the goes to like that. Okay, so this is the maximum thing, and here we want to just choose with the only q na q, what is the possible way of the color, the final touch is what. Okay, so that the thing we want to decide. This is one of the forward checking process. The main theme is what na, the keep on track is trying, and then next level it will be moving after the decision making. Okay, so this is one of the example for the forward checking process. Maybe the thing is continue. We don't want to just match with the previous condition, means sometimes the error, or sometimes it's going to lead with the some error or failure. Okay, this is one of the understanding purpose one day. So next the problem, this is one of the important problem for we want to just make with the like the room coloring problem. So till now we have discussed like the map coloring problem. That is a country based the map coloring problem. Here this problem is a room coloring problem. So we are having the house, the particular house we want to color with, or we are going to just map with the some different kind of the color with the some constraints, some rules. Okay, so this is the problem. This is the problem. So K is the kitchen, and H is the hall, and D is the dining room, and store as a storeroom, and then bedroom B1, B2, B3 like that, and then the master bedroom, and then one of the study room is there, guest room is there, and then library also is there. What are all the condition over here means all bedrooms should not colored in the red, only one can. Okay, so we are having the here look at the diagram here. So we are having the master bedroom, and then bedroom 2, and then bedroom 3. So the condition is any only one bedroom it should be maintained as a red color, so other two we have to maintain the different color. Okay, and then no two adjacency rooms have be the same color. That is a proper, that is a common rule. Okay, there is no adjacency, or there is no or like the neighboring rooms, we don't want to maintain, or we don't want to maintain the same color. That is a condition, that is a common condition for the map coloring rule. The next one as the colors available are the blue color, red color, green color, and violet. And the kitchen should not be colored in the green color. So should the kitchen we don't maintain, or we should not maintain the coloring as the green. So we can choose with the blue color, red color, or violet color. And it is recommended the kitchen should be the colored as a blue always. Okay, so kitchen they have given like the colored as a blue, they have given the proper color. And dining room should not have the violet color. Okay, so this is the thing, and this is the structure. Okay, so this is the room structure, like our building or house structure. So hall, dining, master bedroom, and then K for the kitchen via the storeroom, and then bedroom 2 and bedroom 3. This is the gardening, this is the library, this is the like the study room, like that. Okay, so based upon this structure, now we want to make with the adjacency graph here. Okay, what is the adjacency graph? So here the dining is there. So follow by the before the diagram we want to just make with the constraint graph, like the hall followed by the dining, and then the here the H it will be just connected to the bedroom 3, and then bedroom 2, and then the dining, it can be just connected to the kitchen, and then storeroom, and then master bedroom, and master bedroom, it can be connected to the library, followed by the study room, and followed by the gardening. Okay, so this is one of the, these are all the adjacency rooms. On this dotted line, as here there is no adjacency graph. Okay, that is very important thing. Okay, and just to look at the written notes. Okay, so the variable we can just assign with the b1 to b2 like that, and then coloring we want to take from our constraint: red color, blue color, green color, and then violet color. And the main rule is what now? Adjacent rooms cannot have the same color. That is the main rule. And bedroom, so we are having the only one as the red color, and others we can just choose with any other color. And kitchen, we don't want to maintain the green color, and kitchen we have just maintain the blue color now. Okay, and dining means we don't want to maintain the violet color. Okay, and then we can maintain like the backtracking process and then heuristic process. Here we are going to just apply with the minimum remaining value. That name is called a MRV, minimum possible search. Okay, so it could be represented as a constraint graph. So minimum possible search we want to take, and then the minimum possible way of the process, we will get the clear cut of the colors, and then we will get the reach out the fastest solution also. So that is the meaning for the minimum possible way search. So how it can be represented, we can see the next slide. Okay, and then the next one is the start with the room in the green room. Okay, so we can start with the whatever the adjacency graph. First we can choose with any one of the room. Now first we can assign with the green color. Okay, so this is the thing. So in this problem, always we can just focus with the backtracking, and then good heuristic of value, and then MRV method, that is a minimum and then remaining value. So minimum remaining value means minimum possible search only we will get the answer. Okay, so this is the adjacency like the graph, and then these are all the like MRV method. Okay, minimum possible way. Okay, so what the thing it should be present now, we want to make with the two criteria. Okay, well, two criteria means what? Not two, one column, we have to just put the separate column over here. First, already we are having the some constraint over here. Okay, so here the thing is what now, first we can start with the dining. So dining means what? So dining we are having, we don't want the we don't want to maintain the violet color. What are all the possible color we can choose it, and before that we want to just connect with the adjacency rooms first. Okay, so first we want to make with the D, that is a dining. What are all the adjacency way, like the hall, and then B2, and then B2, and then the kitchen, and then the one master bedroom. Okay, so these are all the possible connection. This is one of the separate. Okay, separate one. Okay, so and next one B2. So B2 as the bedroom, it could be connected like the dining, and then the B3. And B3, what are all the adjacency graph of rooms or regions are connected means B2 and then hall. And H means that is a hall, it can be connected to the B3, and then D, and then the gardening room. And then B1, it can be connected to the dining and then library. K, and then dining, and then the storeroom. So these are all the possible way of the regions. Okay, so whatever the room, it should be presented possible way of the connection. That is a like the adjacency graph, we can connect it with the adjacency graph, and then we can connect it with the rooms. We are the possible ways, or we are just maintaining for the regions. And here we can just fix with the domains. Domains means colors, we are going to fix it. For example, the D, this is the possible of the region, this is possible of the domains, that is a colors. Okay, so now we want to choose with the like what is our main constraint. So here the dining, we don't want to maintain the violet color. What are all the other than the violet color? Red color, blue color, green color. Okay, so now I want to choose like the green color as a thing, because our starting position is what now, whatever the thing. So start thing we can just choose with the green color. Okay, wow, this is our billing only. Okay, so I want to choose that green color. The next one B2. So what are all the B2 conditions over here? So here the D and then B3. Already D we have fixed with the green color. Now we want to choose with the blue color. Okay, yeah. So blue color, the condition is what? Any bedroom, any one of the bedroom we can choose, we can just select at least one of the red. That is the condition. Next one B3. B3, what are all the regions are there, B2 and then H. B2 already we have chosen for the blue color. So the possible thing, okay, the red we want to just choose with the red because the condition is red. Any one bedroom we have to maintain like that. The next one, hall. Hall means what? Always the hall. Hall also we want to choose with the any color. Okay, like what? Na the violet color I want to choose with the hall. Okay. Next one, master bedroom. What are all the region? Dining and then library. Already dining we are having chosen like the green color. So apart from that, the dining there is no adjacency from the there is no no color now at present. So now the master bedroom we can select with the violet color. That is okay. There is no conditions over here. Okay, because the the any one of the bedroom we have chosen like the red color. The condition is already satisfied. Okay, the now the k equal to like what? Now already they have given, we don't want to choose with the green color, but we have to choose with the blue color. Okay, so that the based upon the thing we want to select with the blue color. Okay, blue color or red color, whatever the possibility. Okay, so this is as a minimum search, minimum search of possibility. Okay, so MRV method we can call it. Okay, because what now we have just to segregate the thing. So in the segregate the thing, first we are having the proper adjacency graph. Based upon the proper adjacency graph, we just divide with the first region wise of connections and then the domain or color wise of the connections, and then what are all the constraints they have given. Based upon the constraints also we just follow it. Okay, follow the thing and then we will get the proper outcome. Okay, so this is the condition. Again I am repeating. So all bedrooms we don't maintain the red color, but only one bedroom we can maintain the red color. There is no adjacency with the same color. Yes, we don't maintain the no adjacency as the same color. Yes, we have right, the condition is satisfied. And the third thing is red blue color. Yes, we have chosen these four colors only. And then the kitchen, and we just don't want to maintain the green color, but the blue color, okay, no issues, blue color we can maintain. And then the dining as the violet. So these are all the thing. And these CSP problem, always it should be like finding or coordinating the variable wise, domains wise, and then constraints wise we have to maintain. Okay, so this is the very important problem for solving our room coloring problem. In the first segment we have discussed the map coloring problem, that also one of the important thing. And afterwards we can just discuss with the room coloring with the help of the MRV method. That is a minimum possible search. So based upon the MRV method, we will get the very easiest solution P. Okay, but in the map coloring, we can just one way for using the adjacency process, and as well as the backtracking also there. Backtracking, with the help of the backtracking, we can be very easy to solve this problem, like the map coloring problem. And then the room coloring, with the help of MRV method, we are easy to coordinate the value, and then we can consolidate our final outcome, because we are having the lot of rooms also or that. So with the constraints rule we can apply with the MRV method, we will get the clear cut of the way. Okay, so thank you for watching. Thank you.